Welcome to MindMap MCQ. This is part 2 of the videos on volcanoes. Prepare, practice, prevail. 1. What is the main reason pillow lava forms pillow-shaped structures? A. Due to the high viscosity of the lava. B. Due to explosive volcanic eruptions. C. Due to rapid cooling in water. Or D. Due to interaction with volcanic gases. The correct option is C, due to rapid cooling in water. Pillow lava forms pillow-shaped structures primarily because of the rapid cooling of lava when it comes into contact with cold water, typically underwater. As lava erupts underwater, it cools quickly due to the high thermal conductivity of water, causing the outer crust of the lava to solidify into a skin. The molten lava inside continues to flow and inflate the skin, creating bulbous pillow-shaped structures. This process is characteristic of submarine volcanic eruptions and results in the distinctive morphology of pillow lava. 2. What are pillow lava flows primarily composed of? The options are A. Rhyolitic lava, B. Basaltic lava, C. Obsidian, D. Pumice. The correct option is B. Basaltic lava. Pillow lava flows are primarily composed of basaltic lava. Basaltic lava is rich in iron, magnesium, and calcium with low viscosity and a high melting temperature. The lava's composition includes fine-grained crystals of minerals like olivine and pyroxene, typical of basaltic rocks. Pillow lava flows are common in submarine volcanic environments and are indicative of effusive eruptions where lava interacts with water to form these distinctive rounded shapes. 3. What geological feature is often associated with pillow lava flows? The options are A. Hydrothermal vents, B. Crater lakes, C. Fissure eruptions, or D. Hot springs. The correct option is A. Hydrothermal vents. Hydrothermal vents are often associated with pillow lava flows. These vents are openings in the ocean floor where superheated water and minerals are expelled from beneath the Earth's crust. Pillow lava formations indicate a recent volcanic activity, suggesting nearby magma chambers. The interaction of seawater with hot rock beneath the Earth's crust heats the water and dissolves mineral, creating the conditions for hydrothermal vent ecosystem to thrive. These vents support unique ecosystems and contribute to mineral deposits on the ocean floor. 4. What type of volcanic activity commonly produces pillow lava flows? The options are A. Explosive eruptions, B. Pyroclastic flows, C. Caldera collapses, D. Submarine eruptions. The correct option is D. Submarine eruptions. Pillow lava flows are commonly produced by submarine volcanic activity where lava erupts underwater. The interaction between basaltic lava and seawater causes a rapid cooling, leading to the formation of pillow-shaped structures. Submarine volcanoes, often associated with mid-ocean ridges, hotspots, or volcanic arcs, emit lava that cools quickly due to the high thermal conductivity of water. This process is characteristic of effusive eruptions in marine environments where the lava's interaction with water shapes the distinctive morphology of pillow lava flows. 5. What characterizes block lava flows? The options are A. They are composed of smooth, ropey textures. B. They form large angular blocks due to high lava viscosity. C. They are found primarily underwater. Or D. They have high silica content. The correct option is B. They form large angular blocks due to high lava viscosity. Block lava flows are characterized by the slow, sluggish movement of highly viscous lava with high silica content. This type of lava solidifies quickly, forming angular blocks or clumps as it moves. Block lava flows have a rough, jagged surface and can stack upon each other to create steep-sided mounds or cliffs known as lava domes. They often originate from lava with low temperatures and high viscosity, typical of andesitic or rhyolitic compositions, and are common in dome-building volcanic eruptions. What is a phreatic eruption primarily driven by? The options are A. Lava flows, B. Pyroclastic flows, C. Volcanic gases, D. Steam explosions. The correct option is D. Steam explosions. A phreatic eruption, also known as a steam-driven eruption, is primarily driven by sudden heating and expansion of groundwater or surface water when it comes into contact with magma or hot volcanic rocks beneath the Earth's surface. The water turns to steam explosively, generating significant pressure that can fragment surrounding rock and propel ash, steam, and volcanic gases into the air. These eruptions are typically short-lived and can occur without warning, posing hazards to nearby areas due to the rapid release of energy. 7. Where are phreatic eruptions most likely to occur? The options are A. In volcanic crater lakes, B. In subduction zones, C. Along mid-ocean ridges, D. On the slopes of shield volcanoes. The correct option is A. In volcanic crater lakes. Phreatic explosions are most likely to occur in crater lakes because these lakes provide abundant water that can easily come into contact with underlying magma or hot volcanic rocks. When this water seeps down through cracks and fissures to reach the hot rock or magma, it rapidly heats up, turning into steam. The sudden expansion of steam generates intense pressure, leading to explosive eruptions that eject steam, water, ash, and rock fragments from the crater lake. This interaction between water and heat is a key factor in triggering phreatic explosions. 8. What is the primary characteristic of a phreatomagmatic eruption? The options are A. Non-explosive lava flows, B. Formation of lava tubes, C. Explosive interaction between water and magma, D. Eruption of volcanic gases only. The correct option is C. Explosive interaction between water and magma. The primary characteristic of a phreatomagmatic eruption is the explosive interaction between magma and water, which creates violent eruptions. When magma comes in contact with groundwater, seawater, or surface water, it rapidly vaporizes the water, causing an explosive release of the steam, ash, and volcanic debris. This interaction intensifies the fragmentation of magma, producing fine ash and larger rock fragments. Phreatomagmatic eruptions often generate pyroclastic flows, base surges, and ash plumes, significantly impacting the surrounding environment. 9. Which type of volcanic feature is commonly formed by phreatomagmatic eruptions? The options are A. Mar crater, B. Shield volcano, C. Lava plateau, D. Stratovolcano. The correct option is A. Mar crater. A Mar crater is a shallow, broad volcanic crater formed by a phreatomagmatic eruption where magma interacts explosively with groundwater or surface water. This eruption blasts out rock, ash, and steam, creating a wide, low relief crater often surrounded by a rim of ejected material. Over time, Mars can fill with water, forming lakes. These features are typically smaller and less steep than other volcanic craters and are found in volcanic fields worldwide, highlighting the explosive interaction between water and magma. 10. What differentiates a phreatomagmatic eruption from a phreatic eruption? The options are A. Presence of significant lava flow in phreatomagmatic eruptions, B. Interaction of magma with water in phreatomagmatic eruptions, C. Formation of ash clouds in phreatic eruptions, D. Submarine environments for phreatomagmatic eruptions. The correct option is B. Interaction of magma with water in phreatomagmatic eruptions. A phreatomagmatic eruption involves the explosive interaction between magma and water, leading to the fragmentation of magma and the production of ash, steam, volcanic debris. In contrast, a phreatic eruption is driven slowly by heat and expansion of water when it contacts hot volcanic rocks or magma, resulting in steam explosion without the involvement of fresh magma. Phreatomagmatic eruptions are typically more explosive and generate finer ash compared to the steam and rock fragments ejected in phreatic eruptions. 11. What is an underwater mountain formed by volcanic activity called? The options are A. Sea dike, B. Sea column, C. Seamount, D. Sea risers. The correct option is C. Seamount. An underwater mountain formed by volcanic activity is called a seamount. These submerged volcanic peaks rise from the ocean floor but do not reach the water's surface. Seamounts are typically formed from extinct volcanoes that gradually built up layers of lava. Seamounts are common in various oceanic regions, particularly near mid-ocean ridges, hotspots, and subduction zones. 12. What role do seamounts play in the biodiversity of the ocean? The options are A. They decrease biodiversity by creating barriers. B. They have no significant impact on marine life. C. They only affect the biodiversity of deep sea trenches. D. They enhance biodiversity by providing habitats to various marine species. The correct option is D. They enhance biodiversity by providing habitats for various marine species. Seamounts play a crucial role in enhancing the ocean biodiversity by providing unique habitats for a wide range of marine species. Their underwater topography creates diverse environments from deep sea plains to towering peaks which support complex ecosystems. Seamounts serve as hotspots for feeding, breeding, and a refuge for many species including deep sea corals, fish, crustaceans, and sponges. They promote biological activity for species migrating across oceanic regions, contributing significantly to the overall biodiversity and resilience of the marine ecosystem. 13. What is a fissure eruption? The options are an explosive volcanic eruption, B. a continuous and linear eruption along a crack in the Earth's crust, C. a type of volcanic eruption that occurs underwater, D. an eruption that forms volcanic domes. The correct option is B. a continuous and linear eruption along a crack in the Earth's crust. A fissure eruption is a volcanic event where lava erupts from a long, narrow crack in the Earth's crust called a fissure. Unlike traditional volcanic eruptions that occur from a central vent, fissure eruptions involve the simultaneous or sequential eruption of lava along the length of the fissure. These eruptions are often associated with shield volcanoes and flat basalt provinces where low viscosity basaltic lava flows easily from the fissures, creating extensive lava fields and flat-lying lava plateaus over large areas. 14. What type of lava is typically associated with fissure eruptions? The options are A. rhyolitic lava, B. andesitic lava, C. basaltic lava, D. obsidian lava. The correct option is C. basaltic lava. Fissure eruptions are typically associated with basaltic lava. Basaltic lava has low viscosity due to its low silica content, allowing it to flow easily from fissures over long distances. This type of lava forms extensive lava fields and flat-lying lava plateaus during fissure eruptions. Basaltic lava flows quickly and can cover large areas, contributing to the formation of shield volcanoes and flat basalt provinces, characteristic of regions with extensive fissure eruptions such as Iceland. 15. What is a magma chamber? The options are A. a volcanic vent where lava erupts, B. a deep sea trench formed by tectonic activity, C. a type of volcanic crater filled with water, D. A reservoir beneath a volcano where magma accumulates. The correct option is D. A reservoir beneath a volcano where magma accumulates. A magma chamber is a reservoir beneath the Earth's surface where molten rock known as magma accumulates and resides before it erupts as lava during a volcanic eruption. Magma chambers vary in size and depth and are typically located within the Earth's crust or upper mantle. These chambers can remain dormant for long periods or periodically fill and empty as magma moves into and out of the chamber, influencing the frequency and intensity of volcanic activity in a region. 16. What are lapilli? The options are A. Small pea-sized volcanic fragments, B. Large rounded volcanic bombs, C. Vertical volcanic fissures, D. Submarine volcanic vents. The correct option is A. Small pea-sized volcanic fragments. Lapilli are small, rounded or angular volcanic rock fragments ejected during explosive volcanic eruptions. They range in size from 2 to 64 mm in diameter and typically formed from magma that breaks into pieces as it erupts, solidifies in the air, and falls to the ground. Lapilli can vary in composition and appearance from pumice, which is light and porous, to denser volcanic rock types like basaltic or andesitic fragments. They contribute to the formation of volcanic deposits such as tuff and volcanic breccia. 17. What is a geyser? Options are A. A type of volcanic crater filled with water, B. An underground cavern formed by lava tubes, C. A hot spring that periodically erupts with steam and water, D. A fissure in the Earth's crust emitting volcanic gases. The correct option is C. A hot spring that periodically erupts with steam and water. A geyser is a hydrothermal feature that intermittently erupts hot water and steam into the air from underground reservoirs heated by volcanic activity or geothermal energy. Geysers form when water deep underground becomes superheated, leading to a buildup of pressure until it forcefully erupts through a narrow vent. This eruption is typically accompanied by a column of steam and hot water, followed by a period of relative quiet as the reservoir refills. Geysers are rare and found in geologically active regions worldwide. 18. How do geysers differ from hot springs? The options are A. Geysers have higher mineral content, B. Geysers erupt periodically while hot springs flow continuously, C. Geysers are colder than hot springs, D. Geysers are only found in tropical regions. The correct option is B. Geysers erupt periodically while hot springs flow continuously. Geysers and hot springs both involve heated water from underground, but they differ in how they release this water. Geysers erupt intermittently, shooting hot water and steam into the air due to pressure build-up in underground chambers. In contrast, hot springs release heated water continuously or periodically without explosive activity. Hot springs can vary in temperature and flow rate, providing stable thermal environments favored by various organisms. Both features are associated with geothermal activity and are found in volcanic or geologically active regions globally. 19. What characterizes a Hawaiian eruption? Options are A. Violent explosion and pyroclastic flows, B. Formation of cinder cones and volcanic ash clouds, C. Submarine volcanic activity, D. Lava fountains and fluid basaltic lava flows. What is the primary reason for the low explosivity of Hawaiian eruptions? The options are A. Low gas content in the lava, B. high viscosity of the lava, C. presence of abundant volcanic gases, and D. rapid cooling of the lava. The correct option is A. low gas content in the lava. The primary reason for the low explosivity of Hawaiian eruptions is the composition of the lava involved. Hawaiian eruptions typically involved basaltic lava, which has low viscosity due to its low silica content. This low viscosity allows gas bubbles to escape easily from the magma, reducing the buildup of pressure that leads to explosive eruptions. As a result, basaltic lava flows smoothly and effusively from the volcanic vents or fissures, creating the characteristic gentle and non-explosive eruptions observed in Hawaiian volcanoes like Kilauea and Mauna Loa. 21. What is ignimbrite? The options are A. a type of volcanic rock formed by the solidification of lava flows, B. a volcanic ash cloud ejected during explosive eruptions, C. a volcanic crater filled with water, D. a rock formed from volcanic ash by pyroclastic flows. The correct option is D. rock formed from volcanic ash by pyroclastic flows. Ignimbrite is a rock formed from the consolidation of volcanic ash and other pyroclastic materials deposited by pyroclastic flows during explosive volcanic eruptions. These flows consist of hot gases, ash, and volcanic fragments that rush down the slopes of a volcano at high speeds. As the flow cools and settles, the deposited materials undergo compaction and lithification, forming a consolidated rock known as ignimbrite. Ignimbrites often exhibit a layered structure and can preserve textures reflecting their turbulent depositional history. 22. What is mafic lava primarily composed of? Options are A. iron and magnesium rich minerals, B. quartz and feldspar, C. silica rich minerals, D. volcanic gases. The correct option is A. iron and magnesium rich minerals. Mafic lava is primarily composed of magnesium and iron rich minerals such as olivine, pyroxene, and plagioclase feldspar. It has a low silica content and high levels of iron and magnesium oxides, which contribute to its fluidity and low viscosity. Mafic lava typically erupts at higher temperatures and forms basaltic rock when it cools and solidifies. 23. What is tuff? Options are A. a type of volcanic rock formed by lava flows, B. a dense volcanic glass formed by rapid cooling of magma, C. a pyroclastic rock composed of volcanic ash and fragments, D. a volcanic crater filled with water. The correct option is C. a pyroclastic rock composed of volcanic ash and fragments. Tuff is a type of rock composed of consolidated volcanic ash ejected during explosive volcanic eruptions. It forms when fine-grained volcanic ash, fragmented pumice, and other pyroclastic materials settle and accumulate. Over time, these materials become compacted and cemented together by silica, calcite, or other minerals, creating a coherent rock. Tuff can vary in color and texture depending on the composition of the ash and conditions under which it was deposited, and it is commonly found in volcanic regions worldwide. 4. What is the primary characteristic of tuff? A. dense and highly viscous, B. porous and lightweight, C. glassy and transparent, D. fragmented and angular. The correct option is B. porous and lightweight. Tuff rocks are primarily porous and lightweight due to their origin from volcanic ash and pyroclastic debris. During explosive volcanic eruptions, molten rock fragments and volcanic ash are ejected into the air. As these materials settle and accumulate, they form tuff. The fine-grained nature of the volcanic particles and the presence of air pockets between them create a porous structure. This porosity gives tuff its lightweight characteristics. 25. What instrument is commonly used to detect and record seismic waves? A. Barometer, B. Anemometer, C. Seismograph, D. Hygrometer. The correct option is C. Seismograph. A seismograph, also known as a seismometer, is commonly used to detect and record seismic waves. The instrument consists of a mass suspended from a frame or housing that remains relatively stationary during ground motion. When seismic waves pass through the Earth's crust, they cause the ground to vibrate, moving the suspended mass relative to the frame. This movement is converted into an electric signal which is recorded on a drum or digitally, providing valuable data for studying earthquakes and volcanic activity.